Section 8.4 is called Applications of Trigonometry. And if you haven't learned to despise the word applications yet, you soon will, because in this book that we are using, the word application is just another way of saying word problems. That's right, it's time to tackle some word problems in trigonometry. Now, the good news about word problems in trigonometry in this chapter is they're all right triangles. So when you're trying to figure out what the picture should look like, because it's nice to draw pictures when you do word problems, you know you're going to be drawing a right triangle. So keep that in mind with what we do. Now, before we do anything else, I need to explain the difference between an angle of elevation and an angle of depression. So an angle of elevation is when you're looking from the horizontal and you're looking up. So what's a horizontal? Well, think of horizon, right? A horizon runs from left to right, right? Flat. This is the horizontal right here. That's the horizontal, right? So when we're talking about the angle of elevation, it's the angle that's from the horizontal and it's looking up. So in this triangle right here, this would be your angle of elevation right there. Now, there's also an angle of depression. An angle of depression is all again from the horizontal, but this time it's looking down. So where's the horizontal in this triangle? Right here. So the angle of depression would be right here. Now, I want to give you an example of something. Let's say that there was a tree. Okay, I'm going to draw this tree. Very simple drawing in math. Don't make your drawings complicated. Tree. I'll even label it tree. And in this tree, there's a bird right at the top of the tree. This is my bird. I know it's not the most attractive bird, but that's my bird. And you are standing a little bit away from that bird and that tree. This is you. You're looking good. Okay? Now, the tree is probably on the ground, and we assume the tree makes a right angle. And there's going to be some question, and the question is going to ask you about looking either from you to the bird or the bird to you. So once you draw that in there, whoa, that's bad. Once you draw that in there, you're left with your right triangle. Now, I want to show you something. If I was talking about the angle of elevation between you and the bird, in other words, the angle of elevation when you're looking at the bird, that would be down here. Here's the horizontal, and you're looking up. So this right here is the angle of elevation. But what if the question says the bird is looking down at you? What's the angle of depression from the bird to you? Almost always people want to put the angle of depression here. But why could that not be the angle of depression? Because the angle of depression is always from the horizontal looking down. This is not a horizontal. Neither of these lines are horizontals. So that cannot be the angle of depression. So how do we find the angle of depression? Well, you have to start by drawing the horizontal. So the horizontal runs like this. And so the angle of depression is in here. This is the angle of depression right in there. Okay, more good news. What if the angle of elevation was 60 degrees? Let's just call it 60 degrees. Well, this is 90 degrees here, so you should be able to figure out this amount right here. 60 plus 90 degrees is 150. How much more do we have to make it 180? This is 30 degrees. Now, if this is 30 degrees, how much is this here? Well, this is a right angle. So if this is 30, this is 60 degrees. Hey, what do you notice about the angle of elevation and the angle of depression? They are exactly the same. This will always be the case. This is very exciting. It makes your life a lot easier. When they start asking you about angle of depression and you have to end up drawing an angle outside the triangle, it's really easy. All you have to do is say, if I want to find this angle, the angle of depression, it's exactly the same as finding the angle of elevation down here. You might remember when you did geometry in grade 9 that when you can draw, you have two parallel lines here. Here and here are parallel lines. And when you can draw a Z with those parallel lines, in this case it's a backward Z, the angles which are in the armpits of the Z, I call it, so in here and here, are always equal to each other. So that's always going to be the case with the angle of depression and angle of elevation. They're always going to be the same because they're alternate interior angles, we say. Okay, let's do a few questions. The world's tallest totem pole is in Alert Bay, British Columbia. 20 feet from the base of the totem pole, the angle of elevation of the top, I think it should say the angle of elevation to the top of the pole is 83.4 degrees. How tall is the totem pole to the nearest foot? Alright, well, let's draw the totem pole. Here's the totem pole. Done. Don't make it fancy. The totem pole is sitting on the ground. You're looking from the ground up to the totem pole. This is the angle of elevation. You end up with a right triangle. You're always going to get a right triangle. Now, what do you know? 20 feet from the base. Well, here's the base of the totem pole, and we're talking 20 feet away. The angle of elevation is 83.4, so this is 83.4, right? From the horizontal looking up, this is the elevation. We want to know how tall is the totem pole, so we want to know this right here. Okay, we're going to either use sine, cosine, or tan. So we look from the angle we know, which is this one. What are the two sides we know? We know, or which are the ones we're interested in? We're interested in this one, because this is the one we want to know, that's opposite. And we're interested in this one, this is adjacent. Which one of our ratios are opposite and adjacent? It's tan. So tan of 83.4 degrees equals opposite, which is x, over 20. Put this over 1 and cross multiply. 1 times x is x, and then 20 times tan 83.4. If you take your calculator and go 20 times tan 83.4, you will get 173 feet. That's a very tall totem pole. Alright? Next one. What's the area and the perimeter of this isosceles triangle? Remember the formula for area? Area of a triangle is base times height divided by 2. Okay, well there's our base. The height is from the highest point straight down, and we don't know that amount, so that's what we need to find. How are we going to do that? Well, first of all, this word here, isosceles, we've talked about this before. What's isosceles mean? It means 2 of the 3 sides are equal to each other in this triangle. Which sides are equal to each other? Well, we have to assume a little bit, but wouldn't you agree with me that it sure looks like these 2 sides are equal to each other? I think so. Now, the other thing we need to know, so I can show that with this, right? Remember doing that before? That shows that those 2 are equal to each other. The other thing we know in an isosceles triangle, if 2 sides are the same, 2 angles are also the same. Which angles are the same? The angles across from those sides. So these ones, or this angle is across from one of those sides, and this angle is across from them. So this one's also 66 degrees. Alright, when we cut this in half, like we want to know the height, right? This is what we need to know right here. This makes a right angle right here, or on the other side if you want. So I'm just going to draw this right-hand side of it here. So this is the height there, that's the height. Then I have this, and I have this. Okay, what do we know? We know this is a right angle. We know this is 66 degrees. We know this amount right here. How much is this? Well, you can only do this if it's isosceles. If this was 66 and this is 65, you can't do this. But since they're exactly the same as each other, 66 and 66, that means it cuts this right in half. This is 3.1 centimeters. Okay, I'm going to say that again. You can only do that and cut it in half like that if they're both the same, 66 and 66. If it was 66 and 65, you couldn't just cut it in half and say 3.1. Only when it's isosceles. Okay, what are we trying to find out here? We're trying to find the height. We're trying to find this right here. How do we do that? We look from the angle we know and we ask, what are the sides we're interested in? We're interested in opposite and adjacent. Whoa, it's tan again. Tan 66 equals x over 3.1. Put it over 1. 1 times x is x, and then 3.1 times tan 66. If you multiply 3.1 times tan 66, you will get basically 7.0. So it's 7.0 centimeters. Now remember, what we're trying to find is the area. So the area equals base. Don't take the 3.1. It's the whole base of this triangle, 6.2. Times the height. Well, we just figured out the height. The height is 7.0 from here to here. So 6.2 times 7.0, or just 7, divided by 2. You do that, you'll get 21.7 centimeters. We're talking about area, so it should be centimeters squared. Okay, we still need to find the perimeter. How do you get the perimeter? You add all the different sides together. So we know the 6.2. We need to know this one out here, and we need to know this one out here. But what do you know about those two? They're the same. So you really only need to know one of them. All right, I'm going to redraw this triangle again. Right angle, 3.1, 66 degrees. You could put the 7 over here if you want, but you don't need to. And we want to figure out this side here. I'll call it y this time. So which of the sides we're interested in this time? If we look from the 66, we're interested in adjacent and hypotenuse. Which ratio is adjacent and hypotenuse? Cosine. Cosine of 66 degrees equals adjacent, which is 3.1, over hypotenuse, which is y. Okay, notice this is the one where you have the y on the bottom, the variable on the bottom. So it's going to switch places with the cosine 66. So y equals 3.1 over cosine 66 degrees. And if you put that in your calculator, you're going to get 7.6 centimeters. Now, we finished? No, because we still need to know the perimeter. The perimeter is equal to the bottom, 6.2, plus this amount right here, which we just figured out is 7.6, plus this amount over here, which is exactly the same. It's also 7.6. Add those together, 12, 14, carry the 1, 7, 21.4 is what you get. 21.4 centimeters. Perimeter is just centimeters. It's a distance, right? It's a distance around the triangle, and so it's not centimeters squared or anything, it's just centimeters. Okay, one more question. During a storm, a 10-meter telephone tall, 10-meter telephone tall. Gosh, this is not good. I'll change this, and when you get your sheet, it'll be correct. During a storm, a 10-meter telephone pole was blown off its vertical position. The top of the pole was then 9 meters above the ground. What was the angle of depression from the top of the pole to its base? Okay, so the telephone pole was like this. Here it is, sitting straight upright. But then what happened is it got blown over. So the wind blew and it fell over a little bit like this. Didn't fall all the way over. So obviously it's not a right angle anymore. And what we're interested in is, let's just make this a little easier for us. It'll just look like a right triangle. What it now says is from the top of the telephone pole straight down, it is 9 meters now. So this is the top of the telephone, straight down, it's 9 meters. The length of the telephone pole didn't change. It's still 10 meters. This is a right angle, and we want to know what's the angle of depression. Remember, this is not the angle of depression. The angle of depression is you have to draw in a horizontal. This is the angle of depression. But what do you know about this angle? This angle is the same as, if you look at your Z here, it's the same as this angle right here. That's the angle of elevation. So if you find the value of this angle, at the same time you'll also be finding the value of this angle. So it's much easier if we do this. Look from here. Let's call this theta. This angle is theta. So which sides are we interested in this triangle? We're interested in this one, which is opposite, and this one, which is hypotenuse. So we say sine theta, because we don't know the angle, is equal to 9 over 10. Sine theta, if you want, you could change it into a decimal because it's so fast, 0.9. Now, remember, your math teacher is fit. I should have talked about this before because I like to bring this up a lot. Your math teacher is fit and hot. Are you trying to find the angle or do you have the angle? You're trying to find the angle, so you need to use inverse tan, or in this case, sine. So inverse sine, so theta equals inverse sine of 0.9. So remember, on your calculator you're going to put shift sine or second sine or inverse sine of 0.9, and when you do that you'll get 64.1 degrees. And we are finished. So remember, if you get stuck with drawing the pictures and everything, always strive to make a right angle. That will always be the case with these questions. Okay, good luck with the applications of trigonometry. I've had my fun and now it's time to say